Hi, Assalamualaikum. My name is Tazha Nadia Binti Ishak. I'm from Section 4, Group 12, and this is my minor presentation. In this presentation, I am going to talk about erosion and sediment control plan, water reticulation, and cost estimation for the project. These erosion and sedimentation control principles were designed and recommended based on the Urban Stormwater Management Manual for Malaysia, MASMA 2nd edition, which was published by the Department of Irrigation and Drainage, DID Malaysia, in 2012. MASMA's strategy was to incorporate runoff source control, management, and delayed disposal on a catchment-wide, proactive, and multifunctional basis. Following this strategy should result in flood flow reduction, water quality improvement, and ecological enhancement on downstream receiving waters. So the objectives are, the first one is minimizing soil erosion. The second one is preserving topsoil and other assets. The third one is assess root and site management. Number 4 is runoff control and management. Number 5 is earthwork and erosion control. Number 6 is sediment prevention control. Number 7, slope stabilization. And the last one is site maintenance. This layout is a pre-bulk grading ESCP and catchment area division. And on this layout, there are some symbols. The yellow line is temporary earth drain, the red line is a catchment area, the blue box is sediment basin, and there are some other two symbols which are site access point with wash bay and temporary water crossing. So we designed a few things such as temporary earth drain. What is temporary earth drain? Basically, a temporary earth drain is a ridge of compacted dirt which is used to divert runoff to specific location so that the erosion and sedimentation can be reduced during the construction. Furthermore, for erosion and sediment control, we calculate soil loss estimation by using Universal Soil Loss Equation, USLE. After that, we design sediment basin to slow down the runoff. Next is water reticulation. So the objectives are to ensure that the system's layout, pipe size, and pump capacity can effectively deliver water to the entire Zone B. Number 2 is capable of providing water to the whole Plan B during peak demand periods. Number 3 is to integrate a storage system to cater for supply and demand changes and to provide as a backup supply in the case of water supply breakdown. And last one is provide fresh, cold, clean, pleasant, and high quality drinking water. Next is design analysis. First of all, calculation of water demand. We calculate average flow by multiplying the average daily water demand provided by Suruhanjaya Perkhidmatan Air Negara SPAN with the unit or area in our layout plan. Then, peak flow was calculated by multiplying the average flow with a coefficient of 2.5. Then, fire flow. To determine fire flow, the demand for each node was determined to locate a suitable node for hydrant flow. Node 30 was chosen for hydrant flow as the elevation is high from the tank. The value of hydrant flow added was 22.73 liter per second. At the right side of the slide, there are some schematic diagram pipe layout, and we have a few parts, which is part A, B, C, D, and E. After that, we do the checking for residual pressure head and design for tank size by calculating the volume and determine the dimension of the tank. And the last one is we design the suction tank. After that, we have cost estimation. Cost estimate approximates the overall total cost of a project or operation. which includes site clearing, topsoil excavation, cut work, for example, soil excavation and transportation of excavated soil, field work, soil spreading and layering, and soil protection. The cost estimate has a single total value and may have separate component values that can be identified. With a credible, reliable, and accurate cost estimate, a problem overrun can be avoided. From the project, we estimate the total cost of both initial and new proposed level from site cleaning, excavation of topsoil, cut and fill, transportation and compaction. All these considerations include the machinery and operator costs. By implementing the strategy obtained from the value engineering, we achieved a 21% of overall cost reduction with an initial cost is 3856958.34 ringgit and the final cost is 3037363.8 ringgit. That's all from me. Thank you. Till we meet again.